Hello and welcome, engineers. Today we're diving deep into a topic critical for any global application: advanced content delivery network integration. We're not just talking about caching static images, we're focusing on the complexities of dynamic, ever-changing content, especially relevant for social media platforms. By the end of this lesson, you'll have a robust understanding of how to architect CDNs for peak performance and consistency. You'll learn how to tackle challenges that traditional CDNs often struggle with, enabling your applications to truly scale globally. Let's look at our learning objectives for today. First, you'll understand the unique challenges of CDN for social media platforms. Second, you'll grasp the principles behind a three-tier CDN architecture designed for modern applications. Third, we'll cover essential strategies for real-time cache invalidation and intelligent cache warming. And finally, you'll explore practical integration and monitoring techniques to ensure your CDN performs optimally. Let's get started. When we talk about content delivery networks, it's easy to think of simple static file caching. But social media platforms present a unique set of problems. Unlike an e-commerce site where product images might change infrequently, social media thrives on constant, rapid updates. User-generated content, trending topics, and viral posts demand instant global distribution. This isn't just about speed, it's about freshness. Traditional CDNs designed primarily for static assets often struggle to keep up with this dynamic, real-time nature. Imagine a viral tweet that needs to reach millions worldwide within milliseconds, or a user's profile picture update needing to reflect instantly across all regions. This is where engineering around those limitations becomes crucial. We need systems that can handle content changing every second, ensuring that what users see is always the most current version, regardless of their location. This demands a more sophisticated approach than a basic CDN can offer. To truly handle the demands of dynamic content, modern social platforms employ a three-layer CDN architecture. At the forefront, closest to your users, are the edge cache servers. These primarily serve static content like profile pictures and videos and handle the vast majority of requests. Behind them, we have regional caches. These are designed to manage more dynamic content, such as user timelines and trending feeds, with different time-to-live or TTL strategies. Finally, the origin shield layer acts as a crucial buffer between your regional caches and your core backend servers. Its job is to protect your origin from being overwhelmed by cache miss storms, aggregating requests, and preventing direct hits. This layered approach is also where we face the delicate balance between cache warming and cache poisoning. Cache warming is proactively loading popular content into caches, ensuring users get a fast experience when something goes viral. However, warming too aggressively or with outdated content leads to cache poisoning, where incorrect information spreads rapidly. It's a fine line to walk, ensuring both speed and accuracy. Understanding where the CDN fits into your overall system architecture is key. Your CDN sits strategically between users and your regional servers, acting as the first point of contact for every request. It serves cached content whenever possible, forwarding only cache misses to your nearest regional data center. This creates a powerful hierarchical caching system that significantly reduces backend load. A critical aspect of this integration is global session management. Edge nodes need to validate user sessions without constantly hitting your origin servers. We achieve this by caching session tokens at edge locations with cryptographic validation. And for the truly dynamic nature of social media, real-time content synchronization is non-negotiable. When a user posts a new tweet, that content must reach all global edge caches within milliseconds. We accomplish this using a pub/sub notification system that triggers simultaneous cache invalidation and content preloading. Our CDN integration layer comprises four main components: the edge cache servers, the cache invalidation service, the origin shield layer, and the cache analytics engine. Each plays a vital role in ensuring performance and consistency. Bringing these concepts to life involves specific implementation choices. For our edge logic, Cloudflare Workers offer an excellent platform. They allow us to deploy custom code at edge locations to handle cache logic, session validation, and even content transformation on the fly. For the high-throughput, low-latency demands of hot data caching, we typically use Redis-based cache layers at each edge location. This enables efficient cache partitioning, TTL management, and memory optimization. Crucially, real-time monitoring and optimization are non-negotiable. We track cache hit rates by content type, monitor edge location performance, and analyze invalidation effectiveness. This data is vital for automatic cache tuning and capacity planning, ensuring continuous improvement. By implementing these strategies, your system should achieve impressive success criteria, serving 80% of requests directly from edge caches, delivering sub-100 milliseconds response times globally for cached content, and distributing viral content within 200 milliseconds. Major players like Netflix and Instagram use similar architectures, handling billions of hours of content and achieving incredibly high cache hit rates. So by applying these principles, you're building a system that's truly production-ready. To assess your understanding, consider this. How would you design a cache invalidation strategy for a feature that allows users to unsend a message, ensuring it disappears instantly from all timelines globally?